Hello everyone. If you are watching this video, very probably it is because you know that if there is autocorrelation in the specification of the Augmented Dickey Fuller test, the result of the test will be biased. This video will only explain how to use the code that will account for the issue of the autocorrelation. I mean, we'll add more lags until the autocorrelation is disappeared. First of all, I strongly recommend you to read the post that I wrote about this code and also about the issue of autocorrelation. And to read it, you only need to click in one of the links that I left in the description of this video. Now let's see how the code works with the metric rate. Now we see that we wrote the name of the series, that is series, by the way. And we will keep all the rest of the argument as they are here. We are setting p-value equals 0 because all the p-values are larger than 0. And what we want to do in this first step is just to perform the Augmented Dickey Fuller test without any correction for autocorrelation. Let's see. As we can see, this value indicates that there is autocorrelation at 0.05 level of significance. Now, let's change the p-value and let's set it as 0.05 to see what happens. And run it. Now we see that the code added another lagged difference. Before we had 2 and now we have 3 lagged difference because the code at 0.05 level of significance found autocorrelation in the residual with 2 lags. Then it added another lag. Now we see that there is no autocorrelation at 0.05 level. Then the code only added 1 lag difference more. Finally, you can download the code and get a more detailed explanation about the issue of serial correlation by visiting the link below. I hope all this will be useful for you, and please comment if you find any issue in the code or to share your ideas about all this. I know that time is limited, but if you take some seconds and subscribe, you will get periodical notifications about codes that can facilitate your work and videos explaining them. Very much thank you.